Hello and welcome to helpyourmath.com. In this video, we are going to look at the order of operations with integers. Before we look at the order of operations with integers, let's review the operations with integers. First up, we have addition. If the two terms have the same sign, then we add the values and we keep the common sign. So a negative plus a negative is negative, a positive plus a positive is positive. Or if the two terms have opposite signs, then we actually subtract the values and we keep the sign of the larger value. So, for example, if we had negative 6 plus 2, because they have opposite signs, we have a negative and a positive, we would really do 6 minus 2, which is 4, but then since 6 is the larger value, we would write it as negative 4. If we had 6 plus negative 2, we would still do the same thing where we would subtract 6 minus 2 is 4. Since I subtracted from the 6, the 4 gets the sign of the 6. For subtraction, we're just going to rewrite as addition by adding the opposite. So this is the golden rule for subtraction. If I have A minus B, we can rewrite this as A plus negative B. And then once we've done that, we can refer to the rules of addition on how to properly come up with the answer. For multiplication and division, if the two factors have the same sign, then the product or quotient is positive. If the two factors have opposite signs, then the product or quotient is negative. All right, so I'm glad we had this review of the operations with integers. Now let's take a look at the order of operations with integers. Just in case we need to recall PEMDAS, our mnemonic device, or I always knew it as please excuse my dear Aunt Sally. First up, we have parentheses, but really it's any grouping symbol. Grouping symbols include not just parentheses, but brackets, braces, a giant fraction bar, absolute value bars, a radical, just to name a few. And really what it means is it's not just like if parentheses are there, that means you have to do that thing first. If there's something inside the parentheses, so there's a plus sign in the parentheses, then add the values inside. If there's multiplication, we multiply. So the grouping symbols just says if there's something to do within that thing, do that thing first. Once we've taken care of any operations within grouping symbols, then we look for the exponents. We only compute the exponents of the things that are directly next to them, which we call the base. So we would compute by expanding and multiplying if we can. Now, if it's a variable, we don't worry about it. But if it's, 2 cubed, we actually will write out 2 times 2 times 2. Next, we do multiplication and division. We do these from left to right. If the operations are in separate terms, you can do them at the same time, but if they're part of the same term, then we have to go from left to right. And then at the very end, we'll have our addition and subtraction, and we would do all addition and subtraction from left to right, or at the very least, whatever sign is directly in front of that term just stays with that number. So if it's 10 minus 4, you keep the minus with the 4, even if you move the 4 around. All right, so we're going to look at some examples. Always, I encourage you to pause the video and see how you do. Okay, in our first example, we have 5 minus 4 plus 8. Oh, there it is. There's that minus 4 I promised you we would see. So there's two different ways that you can do this. I mean, what I said previously was we go from left to right. And since it's only addition and subtraction, we would just do that. So 5 minus 4 is 1, and 1 plus 8 is 9. The other way we can do this in expressions, especially when we get to variables, I actually will do this other method where I actually start by combining anything with the same sign first, because that's where you get to add the values together. So I might say, well, I'm going to add 8 and 5 because they're both positive, and 5 plus 8 is 13. And then I have 13 with this take away 4, which still gives me 9. So whichever way you want to do this, you don't have to follow order of operations exactly. There is room for interpretation. You just have to make sure you keep the sign with each term. A very common mistake, especially for question A, is people say, well, I have to do the 4 plus 8 first and get 12, and then they end up getting negative 7 as their final answer. But that's not a 4, that's a takeaway 4, but it's a positive 8. So we have to keep the sign with the number in question. Okay, the second example, we have 5 minus 4 times 8. Well, multiplication has priority over subtraction, so we need to multiply, and 4 times 8 is 32. 5 minus 32. Now, if you want to leave it as subtraction, you can, The rule is that you could also rewrite it as addition by writing it as plus the opposite. So the opposite of positive 32 is negative 32. However, now we're trying to add two things with opposite signs, positive 5 and negative 32. So we go back to subtracting. 32 minus 5 is 27, and the 27 gets the sign of the 32. So our final result here is negative 27. I'm just going to put a box around our answers. Okay, now you're looking at letter C and you're like, wait a minute. You have emphasized so much the importance of knowing what an integer is, and here in letter C, I see something that's not an integer. First of all, very astute observation. Kudos to you for recognizing I threw a curveball at you because 2/3 is not an integer. But we can still find 2/3 of 6, no problem. So here, this one has three separate terms. We have the 15, we have this 2/3 times 6, and then we have the 4 squared. If you want to be loyal to order of operations, we would start with the exponent. However, because the exponent and the multiplication occur in two separate terms, you could also do them at the same time if you want to. This is totally up to you. I'll just be true to order of operations this time since I've already bypassed it once. I'm going to leave 15. I'm going to leave the subtraction because that's going to be the very last thing we do. And then 4 squared means 4 times 4, and 4 times 4 is 16. Oops, sorry, I did my multiplication before the other multiplication, but that's okay. Again, it's okay if I do that because they are separate terms. If it then said times, I might want to be careful about how I'm multiplying. All right, now in the middle, we're going to focus on this 2/3 times 6. So I'm just going to highlight it and let's just focus. I'm going to ignore that sign. We're just going to bring the subtraction down. When I go to multiply a fraction to an integer, we're going to put the integer over 1. We're going to also turn the integer into a fraction. It just makes the multiplication easier. Now, me personally, I like to simplify before I multiply. That means I look in the numerator and the denominator for a common factor. Both the numerator and denominator are divisible by 3. 3 goes into 6 2 times, and 3 goes into itself once. And now I can multiply straight across. 2 times 2 is 4. Over 1 times 1 is 1. And 4 divided by 1 is 4. So the middle term here becomes a 4. We have 15 minus 4 plus 16. Now this one has some resemblance to that first one we looked at. If you know me, you know I'm going to want to add those positive things together first. So I can combine these positives together, thanks to my friend the commutative property. 15 plus 16 is 31, and 31 minus 4 is 27. If you're saying, no, we need to go from left to right. Okay, if we go from left to right, 15 minus 4 is 9, and 9 plus 16 is 27. So we can still get to the right answer, even if we kind of go a little bit out of order. That's because there are other properties of mathematics that hold up that tell me I'm allowed to do that. Pause the video again and see how you do with these last two examples. Okay, so keeping in mind in letter D, we have two separate terms, so we can look at them separately if we want to. The first one's this giant fraction, and the giant fraction also is the part of that first step in the order of operations. It gets lumped into the grouping symbols or the parentheses. And what we do is we need to clean up the numerator. 11 plus 5 is 16. And 16. And then we can't do anything with the denominator. Now, we're going to think about the fact that this fraction is the same thing as division. And 16 divided by 2 is 8. Yay, first term is done. How about the second term? So the second term, we have multiplication and exponents. The exponent happens first. The 3 is an exponent of the 2 only, right? The base is 2. So that means 2 times 2 times 2. Once you write it, if you expand it the way I did, now you can multiply in any order you want, because now everything here is just multiplication. That's up to you. If you want to do 2 times 2 times 2 first, fine, you get 8. If you want to now go from left to right, because we can only multiply two numbers at a time, that also works. 3 times 2 is 6, times 2 is 12, times 2 is 24. If you did the 2 cubed and got the 8, you would have 8 times 3, which also equals 24. So again, as long as you're doing good math, the order isn't super important, right? We just need to make sure we're not doing the multiplication before the exponents, because that would in fact be wrong. Okay, now we have 8 minus 24. We could think of that as 8 plus negative 24. Opposite signs, so we subtract, and we're going to end up with minus 16 as our final answer. In letter E, let's see, here's one term. So again, I'm kind of pointing out the terms. These are the things that are surrounded by plus and minus signs, just because we can do them separately, so they each have their built-in order of operations. And then at the very end, that's when we would put the terms together. That's when we do that addition and subtraction. Whoops, there's only 2 terms in this one. That second term is kind of massive. Looking at the first term, whoops, we have some parentheses, and there's something to do inside of them. 6 minus 3 is the very first thing we do. 6 minus 3 is 3. So now I have 2 times 3 squared. And then I'll just clean this one up, and then I'll deal with that second term. Now I have multiplication in exponents. We're going to do the exponents first. This square belongs to the 3, so that's 2 times 3 times 3. 3 times 3 is 9, times 2 is 18. In my second term, so I'm just going to bring down my minus sign, I need to do what's inside the parentheses first. 2 plus 1 is 3. Once I've done that, I no longer need the parentheses because now I've taken care of the operation that was inside of them. And here's where we want to be careful, because now we have division and multiplication. We go from left to right. So first I'm going to do 21 divided by 7, because that is to the left of the times 3. 21 divided by 7 is 3, and then 3 times 3 is 9, and 18 minus 9 is 9. So we have to be very, very careful in that second term. Sometimes we see the parentheses and we're like, well, that has priority. You're right, but we did the 2 plus 1 and got the 3. Once we've done that, we no longer had a need for those parentheses, and then it's just division and multiplication from left to right. These have been examples of the order of operations with integers. Thank you for stopping by.